quickly go through how we can describe and identify matter. Okay, so we've said before in class that anything that has mass and takes up space is called matter. So when we're thinking about the classroom, just about everything in the classroom is made up of matter. So if it's not matter, it's going to be electrical energy or light or heat or some form of energy. So in chemistry, we study what matter looks like, the composition of matter, and how matter changes. We talked about the interactions between matter. That's what we're talking about when we talk about how matter changes. All right, so some properties of matter. A property is just something that describes what a substance looks like or how it behaves. Chemists a lot of times will observe the substance. They can identify unique characteristics of it. Some characteristics may not be that helpful to chemists if it's not necessarily unique to one compound or one substance. So chemists can use those properties to identify a sample of unknown matter if they are unique to that type of matter. Okay, we can have physical or chemical properties. Physical properties look at what a substance looks like. Okay, so we can observe physical properties without changing the identity of the substance. So if I gave you a sample of silver, you could make observations about the physical properties, that it's lustrous or shiny, okay, but we couldn't really make any observations of the chemical properties by just looking at it. Okay, so chemical properties is how a substance behaves, or how the identity of the substance changes, or what we have to do to change it. Okay, so an example is that alcohols are flammable. Okay, so we could determine that if something catches fire easily, very easily in the lab. Okay, and we can make observations of what happens to the substance when it does come into contact with fire. Okay, so some little more examples of physical properties. Color, odor, texture, density, magnetic properties, and conductivity are all physical properties of matter. Okay, so lustrous, we kind of mentioned, is how shiny a metal is. Ductile is the ability for a metal to be hammered. Malleability is how easily a metal is bent. And then also we look at hardness of metals or substances, the ability of one substance to scratch another. Okay, physical properties sometimes require a physical change to observe those. So melting point, freezing point, boiling point, and ability to dissolve are all physical properties, but they require a physical change so that we can observe them. Okay, when we're talking about chemical properties, things like flammability, reactivity, or volatility, okay, are chemical properties we could observe in the lab. Okay, so real quick, we'll throw in a concept check, and what I'd like for you to do is classify the following as physical or chemical properties. So you may need to pause the video as you think about these. But we've got 4 properties here, and see if you can classify them as physical or chemical. Okay, so the boiling point of a certain alcohol at 78 degrees Celsius is a physical property. The fact that diamond is hard is a physical property. Sugar fermenting to form alcohol is a chemical property. And a metal wire conducting an electric current is a physical property. Okay, another way we can classify properties is by calling them intensive or extensive. So intensive properties do not depend on the amount of substance you have. Okay, sulfur is yellow, kind of the color of the yellow on my walls. But it doesn't matter if you have a milligram of sulfur or 3 kilograms of sulfur, it's still yellow. Okay, so it doesn't depend on the amount you have. Density is another intensive property. The density of gold is always going to be 19.3 grams per milliliter, whether you have a small amount or a very large amount. Okay, extensive properties depend on the amount of substance you have. So if we're looking at the mass of that sample of gold, that's going to change when we have more or less gold. Okay, so if I have 2 blocks of gold and 10 blocks of gold, the mass is going to change there. Okay, we can have physical and chemical changes of matter. Physical changes just involve a change in one or more of the physical properties. Okay, there's no change in the components that make up the substance though. So when water boils, it's no longer liquid water, but it is still water, so there's no change to the fundamental components. Okay, chemical changes though involve a change in the components of the substance. So substances that change into different substances, and a lot of times we also call these reactions. Okay, real quick, let's look at these. We have physical or chemical changes. When iron is melted, iron combines with oxygen. wood burns in air, or a rock is broken into small pieces. Again, if you need to pause to take some notes on these, you can. Okay. Physical change, chemical change, and physical change. All right, so when we're classifying matter, there's different ways to group matter. Some of them are more valuable than others, and a lot of times we're just looking at how simple the matter is, how it can be separated, or how it combines with other substances. Okay, so the purest substances are elements. Okay, those are the simplest pure substances. Okay, they can't be separated by any means. There are smaller components of elements, but once you separate those, it's no longer the element. Okay, pure substances made of only elements are not combined with any other elements. These are the ones you can find on the periodic table. Gold, iron, and oxygen are some examples, and you're looking for one capital letter when you're trying to identify elements. Okay, we can also have pure substances made of compounds, where we have two or more elements that are chemically combined. So water would be an example of a pure substance that's made of compounds, because it's H2O. These can be separated by chemical means, but they cannot be separated by physical means. So there's no way to apply physical changes to water and separate the hydrogen and the oxygen. We would have to apply chemical changes. Okay, when we're looking at pure substances with compounds, we've got more than one capital letter in the formula. Mixtures are another way to classify matter, and so these are just two or more pure substances that are mixed together. They can be separated by physical means like filtration, where we can heat them to cause evaporation of one substance and leaves another behind. Okay, so if we're looking at the alphabet soup over here to the right, how could you physically separate parts of the soup? It might take a while, but you could go through and manually pick out all the A's and the B's and the C's and the potatoes and the peas and the green beans. And you could separate it that way. You could also filter it if you wanted to separate the larger pieces from the broth. Okay, mixtures can also be homogeneous or heterogeneous, and that's going to be important as we start looking at mixtures when we classify them on how we would separate them. When we're talking about separating mixtures, the heterogeneous mixtures, which are irregularly combined, so they may not be in the same proportions across the entire mixture. So I always think of Lucky Charms when I'm thinking of heterogeneous mixtures, where I've got some bowls of cereal that you pour have a bunch of the cereal and not very many marshmallows, and if you're lucky, you get a bowl with a lot of marshmallows and not very much cereal. So that's kind of a heterogeneous mixture. A homogeneous mixture would be something like Kool-Aid. You've got the Kool-Aid powder, the sugar, and water, and that's all going to be mixed up pretty evenly throughout the mixture. So when we're talking about separating those, it's going to depend on how the mixtures are combined, whether it's heterogeneous or homogeneous, and then how we could feasibly separate the mixtures. Okay, so there's different types of separation. We can use manual separation, like I mentioned with the soup. It is time consuming, but like with Lucky Charms when I was little, I went through and did just that. I separated out the marshmallows from the cereal, and I would eat the marshmallows instead of the cereal. It took a long time, but it worked. Okay, distillation is another important type of separation. It uses heat to boil off a solvent. The steam condenses, leaving behind a distillate. Okay, filtration uses a filter to separate components, and sometimes this can require additional filtration or additional separation to separate what's left in the filtrate.